The test of a first-rate intelligence is the ability to hold two opposed ideas in the mind at the same time and still retain the ability to function. Francis Scott Fitzgerald.
Appendices.
In the Appendices section, you will see that within this paradigm, it is possible to have many much simpler and more visual interpretations and understandings of various phenomena of reality. Of course, these are my own interpretations. Upon close scrutiny, some of them may turn out completely wrong, but that does not matter. They are given here only to show that the paradigm of the great life allows us to discover entirely new approaches to understanding reality. And this may not only change many of our notions, but potentially change the very subject matter of the science of physics. I must note, the material in Appendices is more complex. The reader must be ready for a rather bold immersion into the terminology and subject matter of astrophysics, quantum mechanics, atomic physics, and thermodynamics. So, if you feel that all this is too heavy for you, you can, after this chapter, simply proceed to the chapter Appendices Final Thoughts, the very last chapter of the book.
Chapter 1. Biology instead of physics.
In essence, the exposition of the main tenets of the paradigm of the great life is already complete. Let me briefly remind you how this paradigm was built. First, it all began with the concept of the model of the universe. We convinced ourselves that all living beings perceive the universe as their environment. Any living entity recognizes a certain set of events coming from this environment, classifies them as useful or harmful, and knows how to appropriately respond. Second, we found that life by its nature is hierarchical. For example, organs relative to the organism, just as cells relative to organs, represent a lower, i.e. simpler, level of a certain hierarchy, the hierarchy of life. Third, all evolutionary complications of the models of the universe are logical, that is, every successful evolutionary step obeys the laws of mathematical logic. Fourth, by extrapolating the previous 2 points downwards, we came to the conclusion that the simplest model of the universe must be the implementation of the logical operator identity. That is, the statement, the universe is simply everything that is not me. Fifth, as a result of that extrapolation, we saw that a proto-living entity which could adapt such a simplest model of the universe would have to be fantastically stable, not dependent on anything, paying attention to nothing. We also saw that only one hypothetical formation matches that requirement, the substance of dark matter. Only dark matter by definition does not react with anything, neither with matter nor with standard fields. Whoa! And where has this line of reasoning brought us? From biology, from organisms, organs, and cells, we unexpectedly plunged into the physics of elementary particles. And what do we see there? It turns out that physicists long ago began using terminology from the biology dictionary. Particles are born, they have a lifetime, and so forth. In other words, scientists intuitively have for a long time treated elementary particles as elements of life, but categorically refused to admit it. Thus, it turned out that all levels of the life hierarchy lying between elementary particles and cells must also be proto-living, just with progressively more complex models of the universe. In roughly this form, the paradigm of the great life was formed by me at least a couple of decades ago, though then I didn't yet understand that it should be called precisely a new paradigm. I tried discussing these constructs with various people, and each time heard the same thing. Interesting theory, but you do realize it has nothing to do with reality. When I asked why so, I was always condescendingly explained that there is such a science, physics. On the indisputable achievements of this science, the whole modern techno-civilization is built. Unlike any of those unserious psychologies, physics is an exact science. That is, the regularities revealed by it supposedly have the highest predictive power. Surely you're not really going to argue with all of physics, they told me. In truth, I understood that myself. The whole paradigm of the Great Graveyard, though back then I still hesitated to call it that, stands on the apparently unshakable foundation of the science of non-life. Physics. This queen of all sciences apparently gives us quite coherent explanations for most phenomena of observable reality. Imagining all the invincibility of this foundation, I was already ready to forget about all my dualities when suddenly I unexpectedly received support from Boris Strugatsky, a well-known science fiction writer and astrophysicist by education, who at the time I had the chance to correspond with. It was he who appreciated these ideas, found them not merely interesting but productive. His words, "With respect to philosophy, physics is merely an applied science," inspired me to deeply rethink the very foundations of the science of physics. First of all, the conclusion that the simplest model of the universe turned out to be in the sphere of responsibility, not of biology, but of the physics of elementary particles, led me to reflect on the strange state of modern microphysical theory. If you remember, we already discussed in the introduction the crisis of physics. Already in the early 20th century, physicists fiercely protested that all interpretations of microphysical phenomena they observed were literally against common sense. But since those distant times, no alternative interpretations have emerged. So over time, physicists simply got used to the absurd, and one must say successfully continue multiplying it to the present day, seriously discussing even such ridiculous theories as the computer simulation of our reality. I hope now you already guess why this happens. Until the end of the 19th century, physics really dealt only with the non-living part of the familiar macro world, with so-called inanimate objects. But as we remember from the chapter Agency of Matter, any inanimate object is simply an unorganized colony of agentic entities of a lower level of the life hierarchy. So when physics turned to study the micro world, it actually descended to those very lower levels of the life hierarchy, and without noticing it, began to study proto-living agents, while continuing to regard them as the same old non-living objects.
Micro-world physics deals with proto-living agents, while calling them non-living objects.
Therefore,
we must talk about a complete change of the subject matter of physics, about the merger of physics and biology into one new science, duology.
At this point the reader most likely exclaims,
"How can that be? It cannot be that all modern physics is completely wrong, since a huge number of theoretically predicted physical principles, schemes, and laws are well confirmed by practice. Modern technologies are built on the achievements of physics, and all of them work in full accordance with theories based on what the author here shamelessly calls absurdity."
Indeed, the predictive power of modern physics is impeccable, that is, mathematics is flawless. But the interpretations of results definitely and unequivocally do not hold up to criticism. And indeed, try to interpret, for example, metabolism and the life cycle of a living mosquito, treating it as some non-living formation. If you dare take on this venture, you'll have to pile up a cascade of absurd assumptions and ridiculous concepts, from which it will unambiguously follow that the reality of a mosquito is radically different from the familiar and obvious reality we share. In the subsequent chapters, you will become familiar with new, alternative interpretations of certain fundamental aspects of astrophysics, quantum mechanics, particle physics, and thermodynamics, as they appear to me now after many years of reflection. I must point out that I do not even claim these interpretations are flawless. I present them here with only one goal: to show that the paradigm of the great life opens up a vast field of alternative interpretations of what the paradigm of the great graveyard regards as indisputable and inviolable.
Summary.
Microphysics deals with proto-living agents, while mistaking them for non-living objects. What's needed is a complete redefinition of the subject of physics, a merging of physics and biology into a new science, duality.
Appendix 2, Cosmic Superintelligence.
By the end of Part 2, we essentially came to the conclusion that the evolution of life does not begin with the first cell, as the paradigm of the Great Graveyard claims, but with the most primitive elementary particle imaginable. From this it follows directly that
life cannot be limited to the ecosystem of planet Earth. It must be present throughout the entire universe.
And indeed, the organic life we are used to can appear only on planets, but all planets are merely a side product of the vital activity of stars. So it turns out that life must be initiated not on planets, but somewhere in the stars. In other words, our paradigm of the great life not only allows, but explicitly asserts that planetary life is only a small shoot on a very secondary branch of a vast and blooming tree of universal life. The main trunk of this tree is the kind of stellar life that is unknowable to us. That is where the true passions boil, and where reality is genuinely transformed. What does modern science astrophysics actually know about stars? If we state it very roughly, for science stars appear as some strange formations, of course non-living, that somehow, all by themselves formed out of nothing, automatically ignited a thermonuclear reaction inside themselves, and then calmly burn away for billions of years in a row until they either go out or explode. Note that to describe various phases in a star's development, astrophysicists freely use terms like birth, evolution, lifetime, age, death, and other similar words intuitively borrowed from the vocabulary of biology, the science of life. Of course, astrophysicists regard these terms as metaphors. None of them has yet seriously wondered whether these words might be used in the most literal sense of all, but more on that below. And now, a heart-to-heart dialogue between me, the author, and a hypothetical astrophysicist. Author: tell me, dear astrophysicist, in your view, how do stars form and ignite?
Astrophysicist: very simply, in the beginning there was only molecular hydrogen dispersed throughout the universe. The molecules of this hydrogen, under the influence of mutual gravitational forces, gradually gathered into a huge cloud. Then, thanks to the shockwave from some supernova that exploded nearby, this cloud compressed. Its molecules clumped into a single compact lump. Over time, this lump heated up because its mass kept increasing due to more and more dispersed hydrogen molecules sticking to it. As a result of this process, the clump gradually turned into a core, whose mass eventually grew to such values that a thermonuclear reaction of helium synthesis ignited between its molecules. Around this stellar core, a very complex magnetic field formed spontaneously. For example, in the case of our Sun, this field cyclically, approximately every 22 years, changes its configuration, and as a result, the working medium of the core sort of gets stirred. The magnetic field is layered. It wraps the stellar core like bandages wrapped around a wound, keeping the stellar matter from flying apart in all directions, and thereby stabilizing its thermonuclear reaction. Well, is that clear?
Author: No, nothing is clear at all. In practically every single sentence of your story there's room for doubt, but I won't spell out my specific doubts here. They would rely on fairly specialized knowledge that we cannot demand from the readers. I'll just say one thing. According to your account, stars form as the result of a very long chain of random low-probability events that make up a random process. Your science of physics, dear astrophysicist, in the person of the aforementioned Rudolf Clausius with his second law of thermodynamics, claims that there is only one single natural scenario for the development of random processes, and that is destruction, breakdown, decay, and all sorts of further degradation. Applied to your story, if everything really did begin, as you claim, with molecular hydrogen dispersed in interstellar space, then the only thing that should happen, according to Clausius, is that all these molecules over time are obliged to simply fall apart into atoms. In turn, the atoms, and in the case of hydrogen that's just protons, over time should, again according to Clausius, break down into some sort of quarks and neutrinos, which in turn, over time, are also obliged to disintegrate into something else, and so on. That is what is obliged to happen with non-living matter, according to the science of non-life, whereas what actually happens in the universe in reality, but quite obviously unfolds according to completely different laws.
Astrophysicist, smiling condescendingly. The second law of thermodynamics only works in closed systems, while the universe is an open system. In open systems, anything at all is possible. Over unlimited time, even the most unlikely events or combinations of events can occur regularly.
Author: First of all, how unlimited is this time you speak of with such confidence? According to your own Big Bang theory, not quite 14 billion years have passed since the universe began. It is exactly within this completely finite interval of time that between 10 sextillion and 1 septillion of the stars we now observe had to randomly emerge. More precisely, during this time many more stars were formed. That septillion stars is only the net increase, the bottom line. That is, the excess of star births over star deaths. And note, the event death of a star is lawful. We will all die. And yet throughout all this time it has occurred much less often than the random, unlikely event of birth. But even if we ignore all of that, simple calculations show that since your Big Bang, on average, up to 230,000 stars have appeared in the universe every second. Hundreds of thousands of stars per second. Isn't that a bit too high a production rate for random, low probability processes? It looks, much more like some kind of conveyor belt than like irregular draws of a cosmic lottery. Secondly, about these open systems of yours, does it not bother you that random low-probability events can quite happily occur in closed and even in isolated systems as well? For example, there is a perfectly well-defined positive, non-zero probability that inside a sealed glass flask at some moment all the air molecules will suddenly slam together at one single point on its wall and thereby burn a hole right through the glass. Following your logic, dear astrophysicist, that any low-probability event over long times must inevitably occur, If we leave such a sealed flask alone, then after those same not quite 14 billion years, we should find a septillion melted holes in its walls.
Oh, well, all right, not a septillion, but surely we'll get at least a good 50 holes, won't we? Oh, fine, at least a couple. Well, at least one hole for sure, right?
Or not. I am honestly amused by this approach of yours with two different realities. Inside a closed system we have physics by Rudolf Clausius, and outside it, miracles by Harry Potter. It looks like whenever you, dear astrophysicist, failed to give a clear explanation, you simply shove it into the term open system, as if to say, there anything is possible. This, forgive me, reminds me of that amoeba whose model of the universe only works within the limits of its own pond, only unlike you, the amoeba never thought to call an open system that part of the world where its model of the universe is inadequate. And what essentially is the difference between your closed and open systems anyway? Let me remind you that the classical definitions sound like this. A closed system can exchange energy with its environment, but cannot exchange matter with it, while an open system can exchange both energy and matter. Well then, does it not seem to you, dear astrophysicist, that after Albert Einstein wrote down his famous equation E equals mc squared, this difference, in the grand scheme of things, should not exist at all? After all, matter, m, is essentially just energy, E divided by a special constant, c squared. It follows that an open system exchanges with the environment exactly the same energy as a closed system does, doesn't it? The arguments presented above will of course offend our respected astrophysicist, and quite possibly some of the readers as well. And so the author sincerely apologizes for this mocking tone. It's just that if I started explaining the same thing here in strict academic language, then within a minute or two I would have cured most readers of their insomnia. So I hope that not only have I been forgiven, but that I've managed to convince you that, first, random processes are fundamentally incapable of creating. They can only destroy, break down, decompose, and, by various actions, make matter degenerate. Second, astrophysicists, quite predictably, do not have a theory of star formation that deserves our trust, whereas the author of these lines does have such a theory, or rather, not a theory, of course, but the conviction that
stars are agentic entities.
Therefore, the process of the birth and formation of stars simply cannot be adequately described in the terms of non-living nature, that is, in the language of the science of physics. But in the terms of the science of duology, once it arises, the formation of that very hydrogen cloud will be regarded as a certain evolution of agentic entities of a particular level in the hierarchy of life. It is quite possible that as a result of such evolution, hydrogen atoms begin to cooperate and thereby spontaneously form a quasi-organism, some kind of distributed and of course agentic entity of a higher level in the hierarchy of life. This agentic cloud, in turn, evolves from quasi-organism to organism. It arranges the atoms into a specific spatial formation, orients their magnetic moments relative to one another in such a way as to create its own magnetic field so as to protect its body, me, from destructive cosmic radiation, not me. After that, it begins to tackle the problem of its own energy source. It reorganizes its magnetic field, forms and compresses the core, so on. We may judge that stars are not just agentic, but superintelligent entities on the basis of the conclusion from the chapter Quasi-Organisms and Info-Cloning. Let me remind you, there we found that by comparing different forms of life, we can tell which of these forms possesses a more developed model of the universe simply by looking at the ratio of individuality to uniformity among the representatives of that form. Ring a bell? Well then, among the septillion stars in the observable universe, it is practically impossible to find two completely identical representatives. Stars are astonishingly individual. Each one is a unique set of properties and parameters, which means that each of them must be an entirely new and special world, directly expanding their collective model of the universe. Of course, it must be said that so far all this is nothing more than a kind of imaginative gymnastics on the part of the author. These ideas are given here merely to demonstrate the possibility of a completely different approach to making sense of the realities of outer space. The main takeaway is that
all those low-probability random, natural physical processes of star formation are in fact organized, directed and coordinated by life, and as a result they become not just highly probable, but strictly determinate.
However, as we have already discussed in the chapter, Is the World Cognizable?, I am convinced that the process of the birth of the cosmic superintelligence will never become fully understandable to us, since it belongs to a much higher level in the hierarchy of life. After all, we, the cells where when we study stars, are dealing with the very sounds of an airplane flying in the sky that have filtered down to us from the cosmic world of Missy.
And does an even higher level in the hierarchy of life exist?
It appears that it does. That would be stellar clusters, galaxies and clusters of galaxies. It seems to me that galaxies are quasi-organisms of stars, something like an anthill for individual ants. If stars are the superintelligence, then galaxies are a higher level in the hierarchy of life. We might call it the superintelligence. For instance, it knows how to manipulate the gravitational field. It makes galaxies and peripheral stars within those galaxies move much faster than is prescribed by our hopelessly cellular science of non-living nature, physics. We will talk more about this a bit later in the Appendices on physical fields and Does Entropy Increase?
Summary.
Life cannot be limited to the ecosystem of planet Earth. It must be present throughout the entire universe. Stars are superintelligent agentic entities. All low-probability, random, natural physical processes of star formation are in fact organized, directed, and coordinated by life, and as a result they become not merely highly probable, but strictly determinate.
Appendix 3, on subjective time.
In 1905, the special theory of relativity formulated by Albert Einstein made it possible to introduce the concept of four-dimensional spacetime. 10 years later, the geometry of this same spacetime became the key concept of his general theory of relativity. Einstein derived his famous relativistic equation, in which spacetime appears as a single objective reality. However, within our paradigm of the great life, reality is dual, which means that Einsteinian spacetime must be partly objective and partly subjective. It is obvious that within Einstein's pair spacetime, it is precisely space that exists objectively, since it exists independently of me, the observer, right? Which means that time must be subjective. That is, it must fully depend on the observer, that is, on me. Under this interpretation, it turns out that any element of reality must be characterized, first, by its position in objective space, and second, by its state in subjective time. Or in more academic language,
any element of reality, that is, any agentic entity, is characterized not by its position in objectively existing spacetime, but by its position in objectively existing space, plus its state in subjective time.
Let us try to sort this out. From previous chapters we know that the stable existence of any agentic entity in this world boils down to its adequate reactions to external and internal events. However, before one can react to an external event, that event must first be recognized. For example, in order for an antelope to recognize the approach of a lion as the event danger, it must first identify the shape of the object lion. This pertains to objectively existing space, and additionally evaluate whether I, the agent antelope, will have enough time, subjectively taking into account the state of my health, to manage to run away from that lion. If there is little time, one must run immediately and at full speed. If there is plenty of time, then there is no reason to worry. And so together with the antelope, we have used the term time for the first time. But what exactly is it? From the point of view of the antelope and any other agentic entity,
time is an informational concept that makes it possible to relate different events to one another, in terms of earlier, simultaneous, later, and or, to qualify the interval between events in terms of long, not long.
Let us ask the question, is time homogeneous? We have already agreed that time is subjective, and if that is so, then it cannot be homogeneous. Subjectively, a minute spent, pardon the vulgarity, with one's bare backside on a red-hot frying pan lasts much longer than the same minute, with the same backside, but in a comfortable armchair, right? Next, I propose the following interpretation to the reader. Let me note, once again in parentheses, this interpretation may be successful or not. That is not so important. The main thing is to demonstrate a completely new approach made possible within our paradigm of the great life. So, we see that the speed at which time flows is a subjective thing. It can vary across a wide range of values, depending on what we are sitting on, a frying pan or an armchair. Both of these, for us, are sources of external events, that is, events coming from the not me, from the universe. It is obvious that the frying pan generates far more events for us than the armchair. Ow, it hurts! Ow, ow, it hurts! Ow, ow, it hurts even more! Let us introduce the following characteristic, the information density of significant events, hereafter simply info density.
The info density of significant events is defined by the frequency with which events occur that are capable of changing the state of an agentic entity.
To describe the situation we are in, it is not enough to know the info density of external events alone. We must compare this value with the info density of internal events coming from the me. Such events include our pulse, our blood pressure, the intensity of neural activity, and so on. When we are sitting on a red-hot frying pan, the info density of external events greatly exceeds the info density of internal events, and that is why a single minute stretches for us into an eternity. When we are sitting in a comfortable armchair, the info density of external events compared to internal ones is small, and therefore time flies by unnoticed. That is, the subjective speed of time is high. From this it follows,
the subjective speed of the flow of time is the ratio of the info density of internal events, that is, events coming from the me, to the info density of external events, that is, events coming from the not me.
This part seems fairly clear, with the exception of one very interesting phenomenon. When we find ourselves on a frying pan, our blood pressure immediately spikes and our pulse soars sky high. That is, our suffering organism urgently increases its internal, me, info density. In this way, our organism, me, tries to compensate for the increase in the info density of the not me, that is, it essentially strives to keep the subjective speed of the flow of time constant.
Any agentic entity strives to maintain the speed of the flow of time constant by adjusting its internal info density of events to the current external info density.
This conclusion will come in handy for us in just a couple of minutes. For now, let us note one more obvious regularity. The more complex the collective model of the universe becomes in the course of evolution, the greater the number of different aspects of the universe it takes into account and uses, which inevitably forces every agentic entity to process an ever-growing number of external, significant events. That is, the universe increasingly starts to resemble that very same red-hot frying pan for all of us. In other words,
as the collective model of the universe grows more complex, the info density of external, not me, events for all agentic entities steadily increases.
And now, attention, please.
Since, as we know, atoms are also agentic entities, then in principle they too must adjust their internal info density to the info density of the universe. That is, just like our great martyr on the frying pan, they too must, in quotation marks, increase their pressure and accelerate their internal pulse, right? When we sit in a crowded restaurant or find ourselves in a noisy crowd, we involuntarily raise our voice to communicate. That is, we expend more energy. So here a controversial but interesting hypothesis occurred to me. What if, for atoms, the analogue of increasing pressure and pulse is increasing the frequency, and therefore the energy, of the photons they emit?
It's not clear where the author is going with this line of thought.
It is going toward the fact that if the above assumption is correct, then we obtain an alternative explanation for the phenomenon of cosmological redshift observed by astrophysicists. This is extraordinarily important because it allows us to abandon the currently accepted theory of dark energy, which practically cancels the law of conservation of energy and, in addition, gives rise to many other incredible hypotheses and complicating physical theories. Let us recall that redshift is the observed ever-increasing shift of the frequencies of emitted light toward the red, longer wavelength part of the visible spectrum as the sources of that light, galaxies, clusters of galaxies, quasars and the like, are farther away from us. Within the paradigm of the Great Graveyard, redshift is explained by the fact that space itself is constantly expanding. That is, it is believed that while light, an electromagnetic wave, is traveling toward us from a distant galaxy, space continues to expand, and together with space, the light packet also expands, lengthens. As a result, the wavelength increases. If during the flight of the light space has expanded, say, twofold, then the wavelength also increases twofold. Within Einstein's equation, the expansion of space with deceleration is perfectly admissible, and therefore, until relatively recently, the concept of an expanding four-dimensional spacetime seemed to work flawlessly. But in the late 1990s of the last century, astrophysicists unexpectedly discovered that, according to more precise measurements, their non-living universe must be expanding not with deceleration, but on the contrary, with acceleration. In order, while remaining within the paradigm of the Great Graveyard, to somehow explain this accelerated expansion, scientists were forced, in essence, to proclaim the existence of anti-gravity, a strange, dark energy dissolved in space and pushing it apart faster and faster. Thus, Our paradigm of the great life allows us to explain the phenomenon of redshift not by the expansion of space, but by a constant increase in the info density of the universe at an unchanged speed of the flow of universal time. The entire universe continuously evolves, that is, with time it becomes more and more info-dense. If atoms compensate for this increase in info density precisely by increasing the frequencies of the photons they emit, then the farther away the observed galaxy is from us, the more ancient the time from which its light reaches us, the lower the info density of the universe corresponding to that light, and consequently the more strongly that light is shifted into that very red region of the spectrum. We simply see those distant galaxies as they were in those far-off times when the universe had not yet sat with its bare backside on a red-hot frying pan.
It is possible that the phenomenon of redshift may be interpreted simply as the result of the continuous growth of the info density of the universe.
And of course it is quite expected that the info density of the universe should increase not linearly but with acceleration. It seems that the process of cognition always proceeds with acceleration. For example, hardly anyone can deny the obvious fact that the collective model of the universe of the Earth ecosystem is developing faster and faster. Thus, within the paradigm of the great life, the phenomenon of redshift has a much simpler interpretation. Perhaps the universe is not expanding at all, dark energy does not exist in reality, and the law of conservation of energy remains fully in force. Of course, our conclusion is based on the assumption that the frequencies of atomic radiation increase with the growth of the info density of the universe. I hope that scientists will someday take an interest in this hypothesis and test it experimentally.
And how, within the paradigm of the great life, can Einstein's time dilation near large mass be explained?
In our interpretation, large mass is an enormous seething habitat of a vast number of diverse agentic entities. In other words, mass is always a source of external, not me, events. The greater the mass, the higher the info density of this source, that is, the hotter this frying pan. That is why, for any agentic entity near any mass, just like for our sufferer on the frying pan, subjective time will slow down. And finally, let us note that Einstein's general theory of relativity works equally effectively regardless of whether we consider time to be an objective or a subjective quantity. The conclusions formulated here challenge not the theory of relativity itself, but only its generally accepted interpretation.
Summary.
Any element of reality, that is, any agentic entity, is characterized not by its position in objectively existing space-time, but by its position in objectively existing space, plus its state in subjective time. Time is an informational concept that allows one to subjectively correlate various events with one another in terms of before, simultaneous, after, and or subjectively qualify the interval between events as long or short. The info density of significant events is determined by the frequency of events capable of changing the state of an agentic entity. The subjective speed of time flow is the ratio of the info density of internal events coming from me to the info density of external events coming from not me. Any agentic entity strives to keep its subjective speed of a time flow constant by adjusting its internal info density of events to match the current external info density. As the collective model of the universe becomes more complex, the info density of external, not me, events for all agentic entities inevitably increases. It is possible that the phenomenon of redshift may be interpreted simply as the result of the continuous growth of the info density of the universe.
Appendix 4 on physical fields.
In this chapter, yet another possible interpretation within the paradigm of the great life will be presented, a new understanding of the nature of physical fields. Let us rewind history by a few hundred years, back to pre-Newtonian times. Back then, everything was simple. Physics was reduced solely to mechanics, and physical bodies were supposed to act directly upon one another with a certain force, producing a corresponding acceleration. Later, physicists discovered with surprise that some objects act upon one another at a distance. These investigations forced scientists to introduce into usage the concept of a field as a special form of matter, a kind of mediator of interactions between particles, elements of matter. Within the paradigm of the Great Graveyard, modern physics operates with the following physical fields.
The nuclear force field.
This field describes the so-called strong nuclear interaction. It acts over very short distances and allows neutrons and protons to combine into atomic nuclei and to keep those nuclei in a stable state.
The electromagnetic, electric and magnetic field.
These fields act on electrically charged particles and on bodies possessing a magnetic moment. Owing to this field, atoms of different kinds are able to bind into molecules, while atoms of the same kind are able to assemble into crystalline structures.
The gravitational field.
Through this field, interaction is carried out between all objects that possess mass. Physicists believe that it is precisely the gravitational field that shapes the structure of the universe, creating stars, planets, galaxies, and the like. As you understand, all of this consists of formulations of the paradigm of the Great Graveyard. But what is a physical field in our paradigm? Here we have one object. Here we bring another one close to it, and for some reason, these objects begin to interact at a distance, for example, to attract one another. Can we describe this interaction without resorting to the concept of a field? Of course we can. Here you go.
Certain objects, when near one another, change their normal behavior.
And if we additionally imagine that we are not talking about some inanimate objects, but about agentic entities, and we have already arrived at the understanding that the entire universe consists solely of agentic entities, then without invoking the concept of a physical field, their interaction at a distance can be described as
certain agentic entities are capable of changing one another's behavior.
Let us think about whether there exists in our warm and cozy world of cells, organisms, and mind some analogue of electric charge. In the micro-world, certain agentic entities are binary, divided into two camps between whose representatives something inexplicably miraculous occurs. They either gravitate toward one another or, on the contrary, cannot tolerate one another depending on which camp they belong to. What could that possibly resemble? Well, of course, it resembles the division of representatives of our world into two opposite sexes and their mutual attraction and repulsion. Only the representatives of our world are far more complex than those of the micro-world, and therefore the forms of attraction-repulsion in our case are incomparably more complex. In other words,
when it comes to describing interactions of complex, living, intelligent, and superintelligent beings, the concept of interacting fields ceases to work. Instead, we are forced to use the terms of psychology: attraction, sympathies, antipathies, sociology, competition and cooperation, free will, and the like. Field theory works only when we are modeling interactions of very simple proto-living entities, elementary particles.
In the modern physical theory of the quantum field, all subatomic particles are considered as being generated by a field. That is, each such particle represents merely a local oscillation of a field of a certain type. Let us examine one of the central theses of this theory, which sounds as follows.
Everywhere in the world around us, myriads of fields simultaneously exist. Quark fields, electron fields, proton fields. These fields can interact with one another. Energy from oscillations of one field is captured by fields of a similar type.
Let us once again try to rephrase this in such a way as not to mention the word field at all. So,
everywhere in the world around us, myriads of models of the universe simultaneously exist. Models of the universe of animals, models of the universe of plants, bacteria, and proto-living entities. If the model of the universe of certain agentic entities contains concepts of other entities, then upon encountering them, the behavior of those agentic entities is modified.
At this point, it is high time for the reader to protest.
How can the author compare the micro world of atoms and organic chemistry with our macro world? In the physics of the micro world, interactions of particles and fields are predetermined. We can predict with known precision the behavior of, say, an electron in an electric field. But in our macro world, we cannot predict even the behavior of, say, 2 insects, let alone 2 teenagers of opposite sex. Your generalization of the micro and macro worlds simply does not work.
to this I would reply, yes, the macro world is very poorly predictable, but for some reason we constantly forget that the micro world is far from being predetermined 100% as well. For example, when speaking of the nuclear force field, are atomic nuclei really so stably predictable? From time to time, they act willfully, spontaneously, without any visible external influence. They decay into corresponding fission fragments. Why should that be? And is the behavior of those same electrons in electromagnetic fields really so rigidly determined? For instance, among millions of electrons there are always, for some reason, stubborn individuals that somehow inexplicably overcome a completely insurmountable potential barrier. To clarify, this refers to the so-called tunneling effect when a certain potential barrier is overcome by a microparticle whose total energy is significantly lower than that barrier. The tunneling effect is observed for all elementary particles in a wide variety of physical systems. So then, is the tunneling effect not an example of willfulness on the part of charged particles? And as for the gravitational field, something entirely inexplicable is happening there at all. It would seem that nothing could possibly shake Newton's law of universal gravitation. Two bodies possessing mass should always attract one another with a strictly defined force, right?
Well, right, except that this is far from always the case.
First, the mass of bodies themselves for some reason changes over time. In 1875, after the signing of the metric convention, about 40 platinum-iridium reference cylinders with a mass of exactly 1 kilogram were manufactured. These standards were distributed to various countries to ensure uniformity of the system of measures. Periodically, all these copies were compared with the original kept in the suburbs of Paris, and measurements showed that under strictly documented identical storage conditions, their masses for some reason gradually began to diverge. In some countries, the standards were losing weight, while in others, on the contrary, they were increasing their mass, and at different times in different countries, these processes proceeded at different rates. Now, after 150 years, it is already completely impossible to determine which of these 40 standards represents the true kilogram. The mass values of all the standards have diverged so greatly. I mention this because if mass changes over time, then the gravity induced by that mass must also change accordingly. How, then, can gravity be considered unchanging? But that was only first. And second, we observe entirely strange miracles of gravitation in outer space. According to Kepler's famous law, as the distance from the center of rotation increases, the angular velocities of celestial bodies should decrease. And this is exactly how all the planets of our solar system behave. But stars, galaxies, and clusters of galaxies behave in a completely different way. They move as if they were fixed to rigid disks, the agents of the cosmic superintelligence, both near to and far from the center of rotation, rotate with the same angular velocity. This means that as a star moves farther away from the center of rotation of its galaxy, gravity does not decrease, but on the contrary, increases. Within the paradigm of the Great Graveyard, this increase is explained by the presence of that very dark matter we discussed in the chapter, The Hierarchical Nature of Life. However, there is no understanding whatsoever of how the substance of this dark matter manages to accumulate in the disks of galaxies, and not uniformly, but ever more densely as one moves away from the center of rotation. Within our paradigm of the great life, however, such behavior appears to be explainable. In that same chapter, The Hierarchical Nature of Life, we establish that one of the basic skills of all agentic entities is the striving to unite with friends, that is, cooperation. It seems to me that the tendency of all bodies possessing mass to attract one another is precisely a manifestation of that very cooperation. In outer space, this cooperation manifests itself differently for planets and for stars. It appears that superintelligent agentic entities, stars, cooperate more tightly, for to them a galaxy is something like an anthill for ants. There is nothing surprising in this. After all, it does not surprise us that, for example, at our level of the hierarchy of life, the degree of cooperation among members of one family may be many times higher than the degree of cooperation among, say, barely acquainted residents of an apartment building, right? I am convinced that there must be far more unexplainable oddities of the gravitational field. We are simply incapable of detecting them, let alone explaining them. Cells are likewise incapable of detecting, let alone explaining, all the movements of Missy across the lawn solely by the jolts and accelerations they observe. Well then, I hope that by now the reader has acquired, at least at a qualitative level, an understanding of the following.
A field is merely a convenient mathematical model, naturally introduced within the paradigm of the Great Graveyard, to describe the behavior of lower forms of life.
Before closing this chapter, I want to make one more reservation. We are not challenging field theory here, at least with respect to electric and magnetic fields, where this theory deals with very primitive proto-living entities. It demonstrates excellent predictive power.
Summary.
When it comes to describing the interactions of complex, living, intelligent and superintelligent beings, the concepts of interacting fields cease to work. Instead, we are forced to use the language of psychology, attraction, sympathies, antipathies, sociology, competition and cooperation, free will, and the like. Field theory works only when we are modeling the interactions of very simple proto-living entities, elementary particles. The gravitational field is the striving toward cooperation of all agentic entities of the universe, without exception. A field is merely a convenient mathematical model, naturally introduced within the paradigm of the Great Graveyard to describe the behavior of lower forms of life.
Appendix 5. Quantum Agency.
Allow me now to present for your consideration a possible new approach to interpreting the phenomena of quantum mechanics. Within the paradigm of the Great Graveyard, every existing interpretation in this field of knowledge is simply incompatible with common sense. They sound profoundly illogical, utterly mind-blowing to the average person. Take just the theory of multiple and continuously multiplying parallel universes. It seems all this absurdity arises because scientists interpret the objects of quantum mechanics and particle physics as some kind of strange things, as intricately designed mysterious contraptions, as if they were some kind of mechanisms, while in fact they are dealing with proto-living entities. Let us again note that nuclear physicists, just like the astrophysicists we mentioned earlier, readily use terms like birth, lifetime, and death in reference to elementary particles.
Why?
Because it's the most intuitive and easily grasped metaphor. At some point, a particle appears, is born, exists for a while, lives, and then suddenly disappears or decays, dies. But let's return to quantum mechanics and first clarify, what is a quantum? The term quantum comes from the Latin quantum, how much. In the interpretation of the Great Graveyard paradigm, a quantum is an indivisible portion of some physical quantity. For example, people speak of a quantum of light, quantum of energy, or quantum of a field. Physicists also hypothesize the existence of quanta of gravity and quanta of time. Roughly speaking, if the term quantum is used, it means that it simply can't be any smaller. Physicists also use the term quantization, when a measurable physical quantity can only take certain discrete values. And here, I'd like to remind the reader of the entire chapter called Discreteness, which I, somewhat mysteriously, placed at the beginning of Part 2 of this book. There we spoke of how discreteness is one of the properties of life, how any agentic entity perceives reality in the form of discrete, informational events. At that time this conclusion was left hanging in the air, but now, when we understand that absolutely all matter is agentic, we can begin to explain the nature of quantization. Elementary particles, being proto-living entities, just like all living beings, possess threshold and differential sensitivity. We smell a burning pie only when the number of aromatic molecules in the air, the objective text, exceeds a certain threshold, and only then do we perceive the informational event. The pie is starting to burn. Likewise, any elementary particle picks up texts from other elementary particles only when the stimulus exceeds a certain threshold of sensitivity. And let us not forget that all detectors and recorders used by physicists in their experiments are themselves agentic entities, in essence, still the same proto-living observers with their own threshold and differential sensitivity. That's why they can only register discrete values of measurable quantities. Now that I've mentioned the observer, let's dive into the so-called observer paradox in quantum mechanics, the conclusion that mere observation of a phenomenon inevitably alters its outcome. To do that, we must first climb onto the widely disliked platform of philosophy, recall that reality is dual, meaning it is represented by two mutually structuring realms, the realm of energy and the realm of information. We've previously concluded that life organizes energy through information and organizes information through energy. That is, thanks to information, the model of the universe, any agentic entity manages to organize its internal energy, its body. And thanks to organized internal energy, its body, an agentic entity can gather and organize information. Remember that? Keeping this in mind, we now need to expand our understanding of the states of matter before and after the event of death, as well as before and after the event of birth. Recall, we discussed these events in the chapter Death and the Emergence of Life. I solemnly promise, right after this, we'll return to the friendly jungle of quantum mechanics. So let us reflect on the event of death in terms of what was and what is now.
What was when a creature or proto-living entity was still alive?
Answer. This agentic entity existed both in the objective realm of energy, body, and in the subjective realm of information consciousness.
What is now when the agentic entity has died?
Answer. Upon death, it, more precisely, its body, remains only in the objective realm of energy and vanishes from the subjective realm of information. It loses its agency. As a result, the previously organized body energy ceases to be organized, becomes ownerless, and in full accordance with the second law of thermodynamics, begins to degrade immediately. Conclusion.
Everything no longer alive exists only in the realm of energy.
Now let's try to understand the event of birth using the same what was and what is now format.
What was before, say, the fertilization of the egg cell belonging to our infamously overused Missy?
Answer. In the realm of information, there existed a model of the universe for the cellular society of a dog. And of course, in the realm of energy, there was some nearby reserve of unorganized energy necessary to nourish the body for a while after birth.
What is now after the egg cell has been fertilized?
Answer. Upon acquiring agency, it info-cloned, so to speak, an instruction manual for assembly and calibration of the organism loaded to the instinct program and localized, organized in the form of its body, that very nearby, ownerless energy, that is, it appeared in the realm of energy. Conclusion.
Everything not yet alive exists only in the realm of information.
Let's sum up everything above.
Every element of matter, before the event of the birth of life, exists only as organized, yet ownerless information, a model of the universe. After the event of birth, the element of matter becomes an agentic entity, that is, it now exists also in the realm of energy. After the event of death, the element of matter exits the realm of information and continues to exist only in the realm of energy as ownerless, degrading energy.
I hope that makes sense. And now, as promised, with a sigh of relief, we return from the murky heights of philosophy to the hospitable hell of quantum mechanics. Applying our philosophy to the quantum world, we conclude,
every elementary particle, being a proto-living entity, can exist only simultaneously in both equal status realities, the realm of energy and the realm of information. If a particle is not present in one of these realms, then it is either not yet a particle or no longer a particle.
So far, so clear. But let's clarify, what is this ownerless, unorganized energy in the context of the quantum world? It seems to me that in the quantum world, this unorganized energy must be a wave.
The birth of an elementary particle, the event of the birth of life, occurs at the moment when a wave receives agency from some proto-living entity. In other words, when the wave reacts with something.
If this is the case, then within our paradigm of the great life, we can finally offer a coherent explanation for the so-called observer effect, where the mere observation of a phenomenon inevitably alters the phenomenon itself. In quantum mechanics, this effect appears in the classical double-slit experiment. The experiment has two parts. In the first part, a barrier with two narrow slits is bombarded with electrons. Over time, a classic interference pattern appears on the detection screen behind the slits, suggesting the electron is a wave. In the second part, detectors, i.e. observers, are placed near the slits to track which slit each electron passes through. Now the screen behind the slits shows not an interference pattern, but two simple vertical bands suggesting the electron is a particle. To explain this observer paradox, physicists had to invent the monstrously absurd multiverse theory. According to it, the electron passes through both slits at once, but in different parallel universes. When observing the slits, the so-called observer splitting occurs. In one universe, the particle goes through the left slit, in another, the right. But in our paradigm of the great life, there is a much simpler explanation for this paradox. First of all, the electron projector emits not full-fledged particles electrons, but only their not yet alive energy components, waves. In the first part of the experiment, the wave calmly passes through both slits, interferes, and reaches the screen surface. There, one of the proto-living entities, one of the atoms of the screen surface, shares its agency with the wave, turning the wave into a full-fledged particle and thereby organizing under its body the full energy of the wave. That is the very event of birth, in quantum mechanics terms, collapse of the wave function, occurring right on the screen surface. And this newborn particle leaves its mark on the screen. In the second part of the experiment, the wave receives agency earlier, upon approaching the slit, from a proto-living entity, one of the atoms of the detector material. From that moment, the wave becomes a fully fledged proto-living entity and behaves accordingly, like a particle.
A wave is an elementary particle that has not yet been born.
And it also seems that
electromagnetic waves are simply texts exchanged between atoms.
Here's a little fairy tale from the life of electrons to illustrate. Long ago, on some distant star, a little electron shifted from one energy orbit to another, and to notify the universe of this pivotal life moment, it emitted a wave, in other words, a text. This wave traveled across space for billions of years until it finally reached your eye, and then, magic, one of your retina's sensitive cells, shared its agency with the wave, and it transformed into a real photon. For billions of years, no agentic entity in the universe cared about the state change of that tiny electron on a distant star until your eye came along and graciously completed that overdue informational transaction. And, while we're at it, one more important general insight. Within the paradigm of the Great Graveyard, the science of the non-living, physics, assumes that the nature of reality is probabilistic. But from the perspective of our paradigm of the great life, changes in the state of an elementary particle should not be interpreted as random probabilistic events, but as manifestations of a kind of equivalent of free will. Figuratively speaking, the particle just felt like it, and so it changed its state. With this understanding, randomness vanishes completely from our concept of reality. Any manifestation of chaos in the realm of energy is simply the result of misaligned actions of countless independent agentic entities across various levels in the hierarchy of life.
The nature of reality is not probabilistic. Reality changes through the free will of a vast ensemble of diverse agentic entities operating on various levels of the hierarchy of life.
Summary.
Everything not yet alive exists only in the realm of information. Everything no longer alive exists only in the realm of energy. Every elementary particle, being a proto-living entity, can exist only simultaneously in both equal status realities, the realm of energy and the realm of information. If a particle is not present in one of these realms, then it is either not yet a particle or no longer a particle. A wave is an elementary particle that has not yet been born. The birth of an elementary particle, the event of birth of life, occurs at the moment when a wave receives agency from a proto-living entity, namely when the wave reacts with something. Electromagnetic waves are the texts atoms exchange. The nature of reality is not probabilistic. Reality changes through the free will of a vast ensemble of diverse agentic entities operating on various levels of the hierarchy of life.
Appendix 6. Does entropy increase?
In 1865, the repeatedly mentioned German physicist and mathematician Rudolf Clausius proposed the hypothesis of the heat death of the universe. By extrapolating the second law of thermodynamics to the entire universe, Clausius concluded that the universe must eventually arrive at a state of thermodynamic equilibrium, or heat death. For a long time, this conclusion shocked the general public and inspired science fiction writers. Physicists, however, dispute it, albeit somewhat timidly. Some argue that the universe is an open system, and therefore the very concept of entropy cannot be properly defined for it. Others claim that even in a thermodynamically equilibrated but infinitely large universe, random local fluctuations will always produce local regions of low entropy. But as you may recall, we already discussed both of these arguments in the Appendix Cosmic Superintelligence. From the chapter on energy and information, we remember that the entropy of a system is the degree of its chaoticity. Thus, an increase in entropy means an increase in chaos. For example, universe System A, in which hydrogen atoms are uniformly dispersed throughout space, exhibits a high degree of chaoticity. To predict the state of such a system even 1 second ahead, we would need highly precise knowledge of the coordinates and instantaneous velocities of each individual atom in that universe. Now consider another universe, System B, identical in volume and total mass. But where that same hydrogen has formed stars, those stars are organized into galaxies, and those galaxies are structured into clusters. Surely you would agree that the degree of chaoticity in this universe is far lower than in System A. Predicting its state in the next second becomes significantly easier, at the very least because most of its atoms are grouped into stars and galaxies whose trajectories can be generalized rather simply. Therefore, if the Big Bang theory is even partially correct and the universe once transformed from something resembling System A into something resembling System B, then its entropy must have been continuously decreasing. Isn't it obvious?
If you've brought up the Big Bang, then please begin not with uniformly scattered hydrogen atoms, but with the ultra-dense quark-gluon plasma of the Big Bang.
Very well, if you insist, let us connect our paradigm of the great life with the Big Bang. At the initial stage of the universe's formation, When it was merely a boiling broth of incandescent quark-gluon plasma, the realm of energy consisted solely of high entropy energy, while the realm of information was empty. Empty means that life had not yet discovered a single regularity, a single rule, not a single constant. Life had only one single, so to speak, hypothesis, that very same identity operator, me, universe. In the crucible of quark-gluon plasma, unimaginable billions of unique elementary particles came into being every nanosecond, each equipped with the simplest possible model of the universe. The universe is everything that is not me. The uniqueness of these particles lay in their unique sets of properties. Physicists would say they possessed unique sets of quantum numbers. These properties did not allow them to survive amid the enormous random energies of the gluon plasma, and so their lifetimes were vanishingly short. But eventually, after countless attempts, the first particle appeared, whose properties suddenly allowed it to survive in this infernal cauldron of boiling energy. As we recall, this must have been either a dark matter particle or a neutrino. In this way, life made its first true discovery. It found the values of the so-called fundamental physical constants. It felt out the compromise and minimax points that form the fine-tuning of the universe. At that moment, the first law, the first model of the universe, appeared in the realm of information. From then on, the quark-gluon plasma no longer had to probe randomly. It simply began info-cloning this particle. And most importantly, at that same moment, the realm of energy became slightly more predictable. Its entropy decreased, if only by a tiny amount. Within our quark-gluon plasma, particles with short lifetimes could also be born, but in the dense plasma broth they managed to combine, to merge, with other, not quite stable particles. As a result, new, complex, yet stable, particles emerged, carrying more sophisticated models of the universe. With the appearance of each such particle, the plasma, that is, the universe, became progressively less chaotic. Low-entropy energy increasingly replaced high-entropy energy. Thus gradually, through the evolution of matter in the realm of energy, new levels of low-entropy energy emerged, while in the realm of information, new laws were discovered and accumulated, optimal values of constants were found, and so on. But let us return to the stars. Have you ever considered that stellar thermonuclear burning is a reaction of synthesis, and that synthesis is always a process of organization, a process of structuring, a process of increasing the complexity of matter? Surely you would agree that the entropy of a helium-4 nucleus, the result of nucleosynthesis in stars, is lower than the entropy of 4 separate independent protons. That means stars are not burning, they are self-perfecting. That is, they are ordering the universe.
Yes, but stars lose enormous amounts of radiant energy, and those are the very irreversible losses that should lead the universe toward heat death.
Not exactly. From the sun's perspective, photon emission is indeed an irrecoverable loss of energy. But for the rest of the universe, it is precisely the opposite. It is energy of creation, because thanks to it, life flourishes at lower levels of the hierarchy. Indeed, stars generate a continuous and unidirectional stream of photons. Continuity and directionality are already far from chaotic. Such energy can be harnessed and used for creation, which at least one planet in the solar system, Earth, has done quite successfully. For example, Earth's plants discovered photosynthesis. They learned to use this continuous unidirectional photon stream. As a result, chemical energy accumulates, complex hydrocarbons, cellulose proteins, fats, sugars, and so on. This is new energy, chemical one, far more intelligent than a simple stream of sunlight. Because this new energy became available, life could develop further and continue to create. Eventually organisms, animals, appeared that transformed the chemical energy of plants into kinetic or muscle energy. Then humans appeared, and thanks to that kinetic energy they ploughed fields, built roads, and populated continents. Later, as we know, humans discovered electricity, dammed rivers, learned to split the atom, that is, they mastered new, far more intelligent forms of creative energy. And all of this happened only thanks to the sun's energy of creation, that very continuous and unidirectional photon stream. Thus, as the energy of creation moves upward through the hierarchy of life, it transforms into increasingly intelligent, low-entropy forms. This transformation requires ever more developed informational support, ever more sophisticated models of the universe. If we accept that all matter, every single one of its elements, is either proto-living, living, intelligent, or superintelligent, then all these countless local entropy reductions at all levels of life's hierarchy together produce this universal globality. Thus we arrive at the conclusion:
all agentic elements of matter are engaged in nothing but lowering their entropy, and from this emerges the global process of decreasing the entropy of the universe.
That may be so, but alongside the self-perfection of living matter, there is also the opposite process, the degradation of non-living matter, and that process leads to an increase in entropy.
True, but as we remember, only the very top, the outermost level of the hierarchy of life can be non-living. All the other levels remain living. There is simply more life than non-life, so life, in a sense, wins. Still, we must admit that life's victories over non-life cannot continue indefinitely, and here is why. Intelligent, and especially superintelligent levels of life inevitably encounter texts that seep down from higher levels of the hierarchy during the process of cognition. For example, they observe the anomalous motion of peripheral stars in galaxies. Since phenomena belonging to higher hierarchical levels cannot be adequately interpreted at lower levels, recall the chapter, Is the World Cognizable? Attempts at such interpretation inevitably produce an inadequate model of the universe. For example, that anomalous stellar motion gets explained by invoking some kind of dark energy. From the chapter Spontaneous Improvement, we know that the process of cognition of the universe always accompanies its transformation. Once we learn something, we immediately begin to implement it. Attempts to transform the universe using an inadequate model of the universe will sooner or later lead to accidents and catastrophes. And if such an erroneous theory is implemented by some super-duper superintelligence that has already managed to seize control of, say, half the resources of the universe, then the death of that super-duper superintelligence becomes a catastrophe of truly cosmic proportions. It triggers cascading collapses across many lower levels of the hierarchy of life. Stars explode, planets perish in fire, inhabitants die, their organs and cells perish, molecules decompose, and so on. It is entirely possible that such a great cosmic Chernobyl is precisely that big but not so big bang about which cosmologists and astrophysicists have theorized for more than half a century. Thus, as a result of such an inevitable and lawful catastrophe, some portion of the universe once again turns into dispersed atomic hydrogen. The local entropy level there spikes sharply, and the entire life cycle in that segment of the universe begins anew. The remaining part of the universe stays structured, and info clones its models of the universe into newly emerging agentic entities of the cosmos. It is not impossible that the ultra-ancient galaxies and black holes discovered in the very first months of operation of the James Webb Space Telescope are artifacts of that old portion of the universe that survived the not-so-big bang. But catastrophe may occur not only through misunderstanding, but also, let us put it this way, because of unbridled curiosity. Imagine you are calmly sitting at home, reading a book, when an impudent fly begins circling you, buzzing annoyingly. Note, it's not really harming you, just irritating you with its buzzing. What will you eventually do? Exactly. After knocking over a vase of flowers and vigorously swatting with a rolled-up newspaper, you will finally smack that fly against the wall. And also note, you will not care why that fly suddenly chose this moment to buzz here, though it had been quietly sitting behind the baseboard for weeks. You will not be stopped by the undeniable fact that the fly is a living being, a marvelous creation of nature, capable of doing things you cannot do and will never learn, for example, fly. You will kill it simply because it behaved too annoyingly in your own home. And roughly the same feeling might arise in a representative of superintelligence, for example, the Sun, toward an annoying subentity, for example, Earth, if that subentity begins to buzz too actively, for example, by probing the Sun with radio pulses. Indeed, Earth itself may have been irritated for at least a century by the overly zealous activity of humanity. It is not impossible that current global climate changes are precisely the reaction of our superintelligent planet to humanity's annoying buzzing.
Summary.
All agentic elements of matter are engaged in nothing but lowering their entropy, and from this emerges the global process of decreasing the entropy of the universe. The entropy of the universe fluctuates up and down, but over large, cosmic spans of time it remains a constant quantity.
Appendix 7. Contact with Extraterrestrial Civilizations.
The book is nearly finished. But before moving on to the conclusion, I would like to address the question of the possibility of our contact with extraterrestrial civilizations. The fact is that the paradigm of the great life leads to the following.
If humanity wants contact, then, strange as it may sound, in matters like this, we must rely on God.
To explain this unexpected claim, I will once again, I promise this is the last time, return to our thoroughly overused metaphor of Missy and the cells. From that metaphor, we remember the vast abyss of mutual alienation and misunderstanding separating the world of cells from the world of Missy. It is perfectly obvious the maximum that Missy's cells are truly capable of, in terms of contact with extra-bodily civilizations, is to receive sperm cells, mysterious visitors, from somewhere out there, from the cellular cosmos, from the world of lawns, dragonflies and grasshoppers. Or if Missy turns out to be Rex, then on the contrary, to launch sperm cells into that world in desperate hope of success for such an inter-civilizational expansion. Whether such an expansion succeeds depends, as we understand, not on the cells themselves, but first and foremost on their cellular gods, on Missy and Rex. Will they want such a civilizational contact to occur? Will they be able to nourish the newly conceived cellular civilization until its own god can stand on its feet? Will they protect it from predators and shield it from other dangers? In other words, we must hope that sooner or later the superintelligent being Earth will concern itself with, so to speak, having a baby. That is, finding somewhere in the depths of space a partner for itself, a planet very similar to our Earth in all essential parameters, On that planet there would be a similar carbon-based ecosystem, and most likely the civilization of local humanoids would be at approximately the same level of development as humanity. From our analogy with Missy, it is clear that she would never mate with some kind of spider or fish. She would only be interested in a similar Rex, and roughly of her own age. It is obvious that superintelligence must possess its own superintelligent methods of communication. For them, distances of millions of light years are like a neighboring street is for us. And with such a civilization, our superintelligent Earth will sooner or later connect humanity itself. For us, it will look like a miracle. No human technology could ever independently ensure such contact, but it will occur, and it will seem to happen all by itself. However, for anything like this to take place, we must make our planet attractive to that other superintelligent planet, to Rex. After all, when we choose a partner, we try not to notice the crooked, the squinting, the lame, or the hunched. We prefer appealing partners, so to speak, without blemishes. The same will apply at the level of superintelligence. These beings will be able, at first glance, to determine the health and attractiveness of any planet. It seems obvious to me that a planet will be considered more attractive the more balanced its ecosystem is. Such an ecosystem should not contain glaring ecological imbalances, for example, massive waste accumulation problems. It should not contain zoo concentration camps, by which I mean the horrific conditions in which animals are currently raised for meat. Killings for entertainment must be eradicated, even hunting, not to mention wars, and so on.
Summary.
Contact with extraterrestrial civilizations can occur only if the superintelligent being, the planet Earth, wants it. Humanity's cosmic purpose is simply to maintain Earth's ecosystem in a healthy and attractive state.
Appendices. Final thoughts.
Well then, by now the picture of the paradigm of the great life should fully reveal itself before your eyes. Of course, the puzzle is not yet completely assembled, fitting the missing pieces, and perhaps even rethinking some parts of the canvas entirely, will now be up to you, dear reader. In the appendices, we simply apply the ideas and conclusions of the first two parts to real problems of physics. As a result, it turned out that stars, as well as galaxies and clusters of galaxies, are superintelligent beings. Earth is also a superintelligent being. Planetary life is merely a secondary branch on the enormous tree of life, while the main trunk of this tree is stellar life. Time is an informational concept that allows events to be subjectively related in terms of earlier, later, and also allows the interval between events to be evaluated in terms of long, not long. We discovered that any agentic entity is capable of recognizing internal, me, and external, not me, events. The ratio of the info density of internal events to the info density of external events determines the subjective speed of the flow of time. Any agentic entity strives to maintain this speed of the flow of time constant, which may provide a very simple explanation for the phenomenon of cosmological redshift. Any interactions of bodies at a distance are manifestations of life. The concept of a physical field is merely a convenient mathematical abstraction, introduced within the paradigm of the Great Graveyard. This concept works reasonably well for the most primitive proto-living entities, elementary particles, but it ceases to work for living, and even more so for superintelligent beings. Based on the mechanisms of the birth and death of agentic entities, one may assume that at the quantum level of the hierarchy of life, a wave is an elementary particle that has not yet been born. It appears that the birth of a particle occurs at the moment when the wave receives agency from some agentic, proto-living entity, that is, when the wave reacts with something. All changes in reality occur solely due to the free will of an enormous ensemble of agentic entities at different levels of the hierarchy of life. The nature of reality is not probabilistic. Any manifestation of chaoticity is simply the result of a lack of coordination in the actions of numerous independent agentic entities. The entropy of the universe fluctuates upward and downward, but over large, cosmic spans of time it remains a constant quantity. The capabilities of any intelligence, including human intelligence, in understanding the universe are limited above by its own level in the hierarchy of life. Investigations of higher levels of the hierarchy are not only meaningless, but catastrophically dangerous. Apparently, the cosmic purpose of humanity is simply to maintain Earth's ecosystem in a healthy and attractive condition. These were the conclusions of the third part of Alexander Neshmonin's book, The Paradigm Shift of Life, New Answers to Old Questions.
Conclusion.
The purpose of this book has been to present to the reader an alternative explanatory framework, leading us to the conclusion that
matter consists solely of an infinitely vast ensemble of interacting, hierarchically organized and evolving, proto-living, living, intelligent, and superintelligent entities.
I am certain that many readers accustomed to thinking within the paradigm of the Great Graveyard are, if not stunned, then at least seriously unsettled and perplexed by this conclusion. The ideas expressed in this book refuse to fit into your established notions about the structure and properties of reality. Therefore you may, consciously or unconsciously, accuse me of the following 5 deadly sins.
Accusation 1. The author has fallen victim to the Dunning-Kruger effect.
In 1999, American social psychologists Justin Kruger and David Dunning published a paper arguing that a metacognitive bias exists, whereby less competent individuals tend to hold higher opinions of their knowledge and abilities than truly competent individuals. This witty assertion sounded all the more convincing because long before Dunning and Kruger, many well-known philosophers and scientists had expressed essentially the same idea. For example, nearly 2.5 millennia ago, Socrates declared in his Dialogues, "I know that I know nothing, but others do not even know that." Confucius observed, "True knowledge is knowing the limits of one's ignorance." Charles Darwin remarked that confidence is more often born of ignorance than of knowledge. And this list could go on. The Dunning-Kruger claim received lively media attention, was labelled the Dunning-Kruger effect, and has since often been used as the ultimate argument in professional and public debates. Indeed, to many readers, everything in this book may look very much Dunning-Kruger-like. The author holds no formal diploma in any of the knowledge domains discussed here, and the paradoxical ideas and conclusions presented sound far too confident. To this I can only reply that the first tentative ideas underlying the paradigm of the great life came to me back in 1998, as described in the first chapter of the Appendices. For more than a quarter of a century since then, these ideas have grown, deepened, and been refined.
Accusation 2. The author's ideas failed the test of Occam's razor.
About 700 years ago, the English Franciscan monk William of Ockham formulated the methodological principle: entities should not be multiplied without necessity, later known as Occam's razor. In essence, this principle states that if several logically consistent interpretations of a phenomenon explain it equally well, one should prefer the simplest. In other words, do not introduce new laws to explain a phenomenon if existing laws already suffice. In this sense, a reader may accuse me of introducing a new law without such extreme necessity, namely uniting under one roof metaphysical realism and anti-realism. Yes, indeed, our dual realism is a new entity. Invoking it is justified only if it leads to a better, that is, simpler and clearer, explanation of reality's phenomena. In the introduction, I mentioned the historical shift from the geocentric to the heliocentric system as an example of paradigm change. Within the geocentric paradigm, a highly developed mathematical apparatus existed that predicted the positions of stars with excellent precision months and years ahead. The same apparatus predicted planetary coordinates as well, but prediction accuracy declined rapidly over time. Scientists continually added new auxiliary variables to their geocentric equations, improving their forecasts. As a result, the mathematical machinery of geocentrism became extremely loose and largely lost its so-called physical meaning. Does it not seem that precisely such a loss of common sense has characterized quantum physics for over a century? The axiomatic foundation of the Great Life paradigm is more complex than that of the Great Graveyard, just as heliocentrism was more complex than geocentrism. Yet its interpretation of reality's phenomena becomes as visual and intuitive as the heliocentric explanation of the planet's formerly erratic behavior.
Accusation 3. To prove his ideas, the author cherry-picks dubious and marginal facts and cites isolated scientists while ignoring vast bodies of texts that contradict his claims.
I would answer that those vast bodies of texts were accumulated within another and here criticized paradigm, one in which results not fitting the framework were either discarded or classified as dubious and marginal. For the same reason, the bold statements of individual scientists cited in this book are often placed by their conservative colleagues into that same category.
Accusation 4. According to the principle of objective truth, the author also should have presented the strengths of the criticized Great Graveyard paradigm.
Indeed, any judicial proceeding requires fair and proportional representation of both the prosecution and the defense. That is true, but the second essential condition is the impartiality of the jury. In our case, the jury is the reader whose worldview has already been shaped by the dominant Great Graveyard paradigm. Therefore, the jury is a priori not on my side. The reader will naturally assume the role of the defense, and I see no reason to assist in that.
Accusation 5. Narrow specialists in various fields will likely find specific flaws in the author's reasoning.
I do not claim to have formulated an impeccably structured scientific hypothesis or theory. I lack both the necessary depth of expertise and the corresponding scientific authority. The main purpose of this book is to offer those very narrow specialists new approaches to explaining reality. All I hope is that after reflection, these narrow specialists will say to themselves, much of what the author writes is science fiction, but perhaps there is something to it. After that, developing new hypotheses and constructing rigorous theories should rest upon their shoulders. The book is finished. Everything has been said, or almost everything that I wish to say. How persuasive have these ideas and arguments sounded? And even more interesting, who might they convince? It is easiest to convince a reader who previously held no beliefs. Ideal examples are children. A child reads a fairy tale in which animals speak and immediately forms the belief that animals can speak in human voices. The child holds this belief for several days until attempting to speak to the neighbor's cat, which does not reply. Mother explains that a fairy tale is a fairy tale, and in real life, animals do not speak. And the child instantly, effortlessly changes the previous belief. The hardest is to persuade serious scientists. We are speaking of the most intelligent and talented people of our time, those who astonished teachers from school onward with their ability to think, analyze, and reason. They graduated with distinction, excelled at university, studied many sciences, and read vast numbers of articles and monographs. And scientists' beliefs formed upon enormous bodies of largely mutually confirming information. These beliefs become so unshakable that they often turn into part of personal identity. Very few representatives of the scientific community can summon the strength to admit that reality might be structured entirely differently, that a logical flaw may exist at the very foundation of their worldview, unnoticed until now. Changing a simple opinion is hard enough, but changing beliefs is extraordinarily difficult. Yet this is a secondary difficulty. A far more significant problem is that over many decades within the Great Graveyard Paradigm, entire scientific schools have formed, tens of thousands of dissertations defended, hundreds of thousands of articles and monographs written, university programs structured, grants allocated, and extensive, often expensive, research plans established. For many, abandoning all this would mean not merely the collapse of a scientific career, but effectively the end of the status-driven life they have earned through talent and long years of dedicated labor. But even this is not the main point. One of the core principles of the Great Graveyard Paradigm is the postulate of the absolute knowability of reality. According to it, since reality is absolutely knowable, then sooner or later, any scientific research must inevitably yield a positive result. Under this approach, science becomes, in essence, a domain of long-term or very long-term investment in breakthrough technologies. According to the paradigm of the great life, however, for each level of life's hierarchy, reality is knowable only at levels not higher than its own. This means that humanity's aspirations, at least those directed toward deep space, must be recognized not merely as meaningless, but as fatally dangerous, even suicidal. It appears that humanity's true purpose is simply to maintain its own planet in a good, healthy state, to harmonize its relationship with Earth's ecosystem, nature, as deeply as possible. This claim is truly of civilizational scale. It does not merely disrupt the life of the scientific community, it proposes a change in the strategic vector of development for all humanity. One must admit the probability that such a transformation could occur in the foreseeable future is vanishingly small, and yet one wishes to believe that the ideas and arguments presented in this book may, over time, trigger the painful process of a paradigm shift in life, with all its positive and negative consequences.